This is the final part of the DIY milliometer project. I haven't done any further work on this particular meter, so I'm going to release the schematic and the layout for those who want to try and build it and replicate this. So I'll go through some slides to point out some critical stuff or useful stuff that you might find that you might modify, probably get some better results out of it. So here's again the schematic for the milliometer version 2, which I finally built, and I'll just go over a couple of things here. The most critical chips in this one, of course, are U2 and U3, which are the 1.25 volt reference, which is U3, and the current mirror U2. And then the rest of the chips are probably not that critical except for U5, which is the offset cancellation. So if you want something like 100 millivolts, 100 microvolts, or 100 micro ohms effectively of down to that kind of accuracy, you'd probably choose a good low offset amplifier right for U5. Others, the U4, which are the instrumentation amplifier ones, you should try and keep those with low input bias current, so you don't have to worry about the offset cancellation current that flows in the while you short the inputs at U8. So those are the main things you should look at, and of course the most critical thing here is you want to have the resistors R9 to be able to handle the current and not have a significant temperature rise when 100 milliamps flow through them. So in this particular case, I had chosen 100 ohms, 8 of them in parallel to get 12.5. But I think the better solution would be to just use a reasonably sized, like a quarter watt or half watt, 12.5 ohm or something similar, 13 ohms or 12 ohms in that neighborhood. Basically, with the low temperature coefficient resistor, that might be that will basically give you the best performance because the ambient temperature could change even though there's no significant temperature rise, and that temperature difference will get amplified by the instrumentation amplifier in terms of the error, and so your gain error is going to be larger when you have a larger deviation there. In the current version, I changed out the 100 ohm resistors with a single 12 ohm resistor with 100 ppm temperature coefficient. So that basically results in like 0.01% change per degree Celsius change in temperature. So that's a very decent number to get for a milliometer of this type of accuracy caliber. So I would do something similar in terms of the rating for the temperature coefficient. And the absolute value you can tune out by basically programming or changing the R gain resistor, which is VR1, which will help you set the correct value for a given reference resistor that you may have. The rest of the components, such as the switches, the CMOS switches, that is U1, U8, U9, are just standard parts you can get. U7 is the voltage doubler, again not that critical. U6 is the timer for the offset cancellation frequency, so that again is a very simple chip, you don't have to worry about that. The regulator U11 is just a standard regulator. You should put in some I don't think I have this in the schematic, is a decoupling capacitor on the output of VCC, which you can just solder in there, and any other decoupling you may want to put in addition to what I already have will probably help keep the noise levels down. Our rate sets the frequency at which the offset cancellation occurs, so you can play around with that, and I don't have a means to control the width of that, but you can change that through C2, I believe. And then the other thing is basically you want to have the R4 and R gain, the sum of those two, to be in the right range, so you can actually get the exactly 10x gain that you want at the output. So you may want to just play with that in case your components are slightly off. You want to basically have R gain somewhere in the middle so you can adjust the gain appropriately around that value. Finally, a few comments about the board itself. So this is the front side where most of the components are basically, actually all the components are mounted. The V plus and V minus are the voltage sense, I plus and I minus on the current sense. On the left side, you should have 4 wires that go out to a Kelvin clamp kind of arrangement. The R9 resistors, as you can see on in the middle left side, you can basically use either two 25 ohms or four 50 ohms, whatever combination to get to roughly around 12 ohms, 12 and a half ohms. That will give you the 100 milliamps of current. I would suggest, as I mentioned, go with the 12.5 and get a good quality low tempo resistor if you want to get the best performance. The rest, there's not much to comment about. The components are not that critical. Again, U5 is you may want to put in a socket for that one so that you can replace the chip with a different type. R4 is also not that critical. I did have a socket for it though, and in my demonstration I showed that if you replace it, it's going to give you slightly different values, but you can tune the gain out using R gain. So it's again not critical, just keep the bias current as low as possible. So that concludes this brief video on the schematic and the layout of the milliometer. I'll put in the links for the Gerber file and the schematic file in case you want to play around with that or use that, and hopefully success in building this thing. So if you have any questions or comments, please do write, and if you decide to build this as it is or make modifications, I'd love to hear your results. So please do mention that in the comments below. Thank you.